Good afternoon, everybody. My name is May Reyes, and I'm a part of the AWS team that supports Netflix. Now, I've only been in the Netflix team for over a year, but I just found out that I have been a Netflix subscriber for 17 years. Now, can you see a show of hands? Any Netflix subscribers out there? Anybody longer than 17 years? I see somebody, all right. Awesome. So today, we will talk about the Netflix Maestro. Now, one of the reasons why I've been a subscriber of Netflix for over 17 years is because Netflix actually recommends a lot of shows and movies that I enjoy. And with that, they have a powerful recommendation engine that is powered by Netflix Maestro. We have two Netflix engineers here. We have Junha and Akash who will be talking about Netflix Maestro. And with that, I will hand it off to Jun, who will kick us off. Thank you.
My name is Junhe. I'm a staff engineer in the data platform at Netflix. It's our pleasure today to give this presentation about the Netflix workflow orchestrator Maestro. So let's get started by looking at the landscape of data and ML workflows at Netflix. Thanks, May. Just did a quick survey. Glad to see that we have some Netflix subscribers here. So thank you, and hope you enjoy the show. As you have, and also might have experienced when you watching Netflix, the recommendation you saw is pretty good, which is a result of multiple workflow data pipelines and also the machine learning workflows. And so also Netflix is a data-driven company. Many business decisions is driven entirely by the data insights. So for example, like from the color in the landing page to the investing in the content acquisition, to the training algorithms, even to the detecting some security issues, right? So data engineers, data scientists, and other software engineers, and also even the content producers, all run their workflow or data pipelines to get insights they need. And so we have a wide variety of use cases for data, and the users would like to train their ETL pipelines, or run their ETL pipelines to process data, or train their ML models based on data, or run A/B tests, and so on. So as the company scales globally, and it relies on data to power its business in all phases. So the scalability and the usability of the workflow orchestrator has become very important. So in the past multiple years, we have built this scalable and user-friendly workflow orchestrators for the Netflix users to provide them a consistent way to manage and automate their ETL pipelines. This is Maestro. Maestro is a fully managed service. It provides workflow as a service to thousands of internal Netflix users. Users used to develop their ETL pipeline or do their daily jobs. And so it is reliable and scalable, become a robust foundation. So users just build their business logic, and then Maestro is responsible to manage the life cycle of that. Maestro consists of multiple components. There's a workflow engine, the alerting service, error classification services, and also the Maestro provides the UI and abstraction layers, like a template or the domain-specific language for our users to use and define the workflow easily. So this workflow orchestration system works quite well, including for engineers and even non-engineers. And so instead of being a very simple workflow scheduler, we actually add lots of features into it to make it very user-friendly and plus powerful, such as we provide those patterns for each or sub-workflow and the conditional branches and then user can use those patterns to easily define very complicated workflows in a very simple way. Also, we provide the template support. Like for example, users can run their Spark jobs or Trino jobs very easily by just provide a few parameters. And then the whole complexity of setting up the engine, everything is handled by the Maestro. So our users can just focus on their business logic without worry about those kind of internal details. Also, triggering functions are important. Maestro support like a time-based trigger, such as cron or fuzzy cron. Also, we support the a single trigger as well. So then user can run their ETL pipelines or workflows once the, for example, upstream table partition is ready. So that's very efficient. Security is another important feature to protect our users and also the data warehouse. So you may wonder why we build our own workflow orchestrator instead of using some existing solutions. So we started Maestro project about 3 years ago. So we were unable to find a viable solution for the Netflix scale. And so that kind of is like one of the main reasons for us to make this decision to build our own one. The challenges that we are facing at Netflix. When we talk about scalability, I think it's not only just like a number of workflows the workflow orchestration system has to manage it. It's also about the size of a single workflow, because that's very common thing or request from our end users is that they would like to train their machine learning models, or they would like to run a backfill pipelines for like hundreds of thousand times or something like that, even like a million times we see. So that's very convenient for the users, but put a lot of pressure for the workflow engine. And we could not find a viable approach for that kind of scale. And this example just show kind of pipeline that our users can use to, this is used like a for each pattern. They can easily use that to build this kind of really large scale training or backfill pipelines easily. That's convenient, but we have to deal with that scaling. Additionally, as I mentioned, we have like thousands of users use this workflow engine. They build their daily or hourly ETL pipelines or train their machine learning models. They work with that every day. And so the usability is super important. Because that large user base, right? Users have different preferences or they have different backgrounds. Some may like to write a SQL, some may like to write Python or Scala or Java, whatever. So after like checking those existing solutions, we could not find like a good solution or to solve the problems. So we decided to make our own workflow orchestrator to support all our use cases. So here I show example like that how our users use YAML to define their workflow. This is like a daily workflow, run a Spark job. So you can see that the user just need to provide some parameters like my query, which has the SQL query that the user want to run. They also can provide like a link to their Spark job jar or something. Then the Maestro are going to take care of the whole life cycle of the execution. So the whole the complexity is completely hidden from end users, and then the users can just focus on developing their business logic. Okay, this graph shows the scale of the Maestro. You can see the growth rate is high, and we have a big increase every year. And the Maestro runs like tens of thousands workflows and a million jobs per day. And also the load is uneven and is very spiky, especially at the midnight or the start of an hour. Okay, because Maestro solves both the scalability issue and the usability, then it works quite well to support lots, like a wider variety of use cases at Netflix. Users use it to like schedule their ETL pipelines, which can be like a cron-based or single-based, and they can manually run their backfill jobs for like multiple years. And also we have like many specialized pipelines built about Maestro. For example, we have this open source machine learning framework called Metaflow Metaflow is built and integrated with Maestro. All their production workflows run above the Maestro. And also, other teams build their pipelines use Maestro too, like A/B testing, payments, auditing, or some simple workflows just move data between the data stores. So it becomes a paved path for all the users at Netflix to access data warehouse and run their daily or batch jobs. Okay, this diagram shows our high-level architecture, and users use the UI or client or CLI to interact with the Maestro over the API. And the API gateway is the abstraction layer, provide a public interface for the end users so they don't need to know the details of the workflow engine. And the workflow engine is the core, which manages the states of the workflow execution and also provide a versioning. And it also have the triggering supports, like time-based or the single-based. All the executions is run over the Docker containers, and then there are lots of downstream services. Maestro kind of have integrated with them in a loosely coupled way by emitting some state change events to a Kafka stream. Okay, this is a link to our blog, so it has all the technical details. Next, I'm going to pass the presentation to my colleague Akash.
Hello. Hello. Okay. Hello, everyone. My name is Akash Dwivedi, and I'm Senior Software Engineer at Netflix. Thanks for attending our talk. Thanks, John. Okay. So I'm pretty sure many of you might have faced the challenges creating a suitable abstraction for platforms which powers thousands of users. And we face the same. So in the next couple of slides, I'm going to cover some important critical considerations we made while building Mastro. So the first is interfaces. Mastro offers domain-specific language in YAML, Python, and Java. REST, we have Mastro REST and GraphQL. Can you guys hear me? OK. Next, we have REST and GraphQL interface for the programmatic access. For example, other platforms like Metaflow, they create workflows at a scale using the programmatic interfaces. And next, we have the Mastro UI, using which users can interact with their workflows, look at the previous runs, and debug any issues. Next is the integrations. And Mastro is built for the users. We welcome all the use cases. And if you like working with shell scripts, notebooks, Java, Docker, SQL, Mastro have got them covered. Next important consideration is about the dynamic execution of the workflows. Static workflows are pretty much useless, and pure dynamic ones are very hard to understand. So Mastro approach of the dynamic executions is using the parameterized workflows, where you create parameters in the workflow, and the parameters looks very similar to creating a variable in any programming language, where you can use the parameters, later reference them, pass their references, or use them in the function. Parameterized workflows comes with distinctive features such as conditional branching, and sub-workflows. They are quite powerful, and we will cover some of the examples of the parameterized workflows in the later slides. Mastro also offers dynamic code injection in Java format directly in the workflow definition. They are mostly used as functions, and Mastro executes those in a sandbox environment, ensuring they are run in isolation. And next is the extensibility. Mastro is extensible. Users can create new step types by simply writing some notebooks and associating some parameters for those notebooks. Users can also bring their compute to power their time-critical workloads. And Mastro offers async executions using Signals API that Jun covered, And that's quite useful, especially like, they look very similar to the wait and notify APIs of the programming language, where the upstream workflow want to notify set of downstream workflows when the task is completed. Next, let's explore the DSL offered by the Mastro. So Mastro offers DSL in YAML, Python, and Java. And here you can see the example of a very simple workflow represented in all the three formats. This is a very simple workflow which runs daily at midnight in US-specific time zone. So that is described by the trigger block here. And then this is the workflow, has some ID, has two jobs. The first job is of a Spark type, running a very simple query. And then the second job is of notebook job type, and which points to a notebook like in some S3 location. Same workflow is represented using the Python and Java DSL. So we crafted the Mastro DSL to ensure the workflow definitions are readable, where users can understand what's going on. They can later refer it. Are reproducible so that users can create new workflows by following the patterns used in the other workflows, and are debuggable so that users can see what parameters are passed at the execution time and refer them. Now let's go over a practical example of a backfill workflow. Here we will demonstrate the power of parameterization in the Mastro execution. So this is a very simple workflow, but like we will go over like some of the parameterization. Think about like user wants to run some backfill, and the actual backfill logic is all captured in this notebook, which is stored in S3. So we create a from date and to date, these two parameters very similar to like how we create variables in programming languages, and we pass some values here. And then we have first step, and first step computes the backfill ranges between the from date and to date. And we are using a cell function here, which is date since between. This is offered by Mastro, but you can write your own cell function, similar to like injecting a Java function here. And we are passing the from date and to date references, which in return at the execution time returns the array of dates between the from date and to date. So there are going to be 365 dates here, and which is later substituted to the dates parameter of the first step. Next, we have the for each step. For each step runs the backfill job. Here there is only one job, but there could be a DAG of jobs within the for each. These are all run in parallel, and so the dates parameter of the step one is later referenced by this for each step to create the iterations of those 365 iterations. And then those iterations are later passed down to the actual backfill job, where the date parameter of the iteration is later referenced by this backfill job as arg1, and arg1 is passed down to the into the notebook, where the user's business logic can refer the arg1 parameter and can do the backfill. Next, let's explore the execution abstractions offered by the Mastro. So Mastro offers several step types, like over 30 plus predefined step types with user set parameters. For an example, Spark is good for large scale data processing. Trino is ideal for running queries on large data sets. The notebook step type is ideal for model training or data cleaning or doing any kind of analysis. And these step types cater to the wide range of workflow needs. But users can also bring their custom logic. If they want to run their custom logic, they can bring their custom notebooks or custom Docker image, and Mastro will orchestrate them. Users can also create new step types just by defining the parameterized notebooks and defining the required and optional parameters for the new step type. And they, once they are done, they register the template with Maestro, and Maestro ensures checking their types and the values both at push and runtime. And the beauty of Maestro is it takes care of the scheduling and execution of the workflow. This allows users to focus on the business logic. And Maestro ensures the workflows are executed smoothly and efficiently. Now let's explore the execution used done in the Maestro. So Maestro execution is designed to be efficient, reliable, and user-friendly. And at Netflix, data engineers and data scientists mainly use notebooks. They create their work in notebook and later reference those notebooks in the workflows. In Maestro, each job is run in isolation via custom Docker image that we use. So by default, we use the big data image, which comes preloaded with set of common libraries, OS packages, and runtimes, which saves users time to install those during the execution of the workflow. And Maestro uses Papermill to execute the notebook. So Papermill is a command line tool to execute the notebooks without a notebook server. Maestro passes all the workflow and step parameters in the notebook as the first cell, so users' business logic can refer. Like for an example here, if you see the script parameter is passed to the notebook's first cell, along with some important parameter that Maestro decorate that can be later referenced by the user's business logic. And notebooks outputs are later, after the execution, are exported to S3, and we have the S3 viewer where users can see the notebook outputs. And this kind of execution model is quite useful for the debuggability, where users can see, like, if anything goes bad, they can go and interact with what parameters were passed and can see what's going on. So that's all from our end. Thank you all for attending our talk. And feel free to reach out to us after this talk if you have any questions. Thank you.